Hello friends, welcome back to our channel. This is another video on interview questions and answer series on RTL design. And in this particular video, we are going to discuss some very important questions related to DEMUX coding. Now without wasting much time, let us see what is inside this video. Friends, let us start our session with a very simple question. And the question is, you have to write a Verilog code for 1:2 demultiplexer. In 1:2 demultiplexer, you have one input, one select line and two output signals. It is very simple. Most of you will be knowing it. If you also know its answer, please write it down in the comment section. Otherwise, I am going to reveal its answers. Before going into the coding of 1:2 demultiplexer, let us see what is its behavior. Whenever select line is 0 and whatever is available at its input should be passed at Y0 output. And when select line is 1 and whatever is available at its input should be passed at Y1. Now let us see its Verilog code. Verilog code is shown on your screen. I have given a module name as DEMUX. It has one input IP, one input select line, 2-bit output that is OP. Its Verilog code is very simple as we discussed. Whenever select line is 0 and whatever is available at its input should be passed at OP0. So whenever select line is 0, this statement is true, so IP is going to pass to OP0. And when this select line is 1, this statement will be false, that means 0 will be passed at OP0. And that is an expected behavior from DEMUX. Now OP1. When select line is 1, whatever is available at the input should be passed to OP1. Otherwise, OP1 should be 0. Now let us see your next question. This question is the last question of this session, and in fact this is the crux of our video. And the question is, you have to write a Verilog code for 1:2 and demultiplexer. In this demultiplexer, you have only 1-bit input and n-bit output. Just for your knowledge, n will be always 2 raised to power x. X can be any integer number. For example, it can be 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5 and so on. And it has m select lines. M will be always log of 2n. Now let us see its Verilog code. Friends, I will write the Verilog code of generic demultiplexer in two different ways. Both of them are important, so I will recommend you should learn both of them. Let us see the first method. Here module name is DEMUX and I am declaring a parameter n. For the time being I am taking the value 2. N is equal to number of output signals. Input for demultiplexer is always 1 bit, and now select line will be equal to log of 2n. As I explained in the explanation also. Now let us see the body of the code. I have declared a genvar variable I, generate for loop which goes from 0 to n minus 1, that means n number of iterations, and in each iteration I am incrementing I by 1. Why I am keeping a loop for n iterations? Because output signal OP is n bits long. In each iteration I will form one assign statement. And in each assign statement, I am going to evaluate one of the bit in vector OP. Now when I is equal to 0, OP0 will be equal to, when select line is equal to 0, because I is 0 here, whatever is available at the input IP will be assigned to OP0, otherwise OP0 will remain 0, which is expected behavior of demultiplexer. Now when this I will be incremented by 1 and this I will go 1, now OP1 will be equal to, when select line is equal to 1 and whatever is available at the input IP will be assigned to OP1. Otherwise, OP1 will remain 0. And so on. This is the first method to write a generic demultiplexer. Now we will discuss the second method. Friends, now let us see the second method. In fact, I like this method very much. This is a very powerful feature of Verilog which enables us to write very complex codes in a very simple form and without using any type of generate for loop or for loop. Here DEMUX body is same only, parameter n. Again I am taking the value of n as 2 here. Input IP which is 1 bit. output OP, it is n bit long, and select line is log 2 n bit long. Now let us focus on the body of the module, which is very important for us. Here I am using always block, and for always block sensitivity list is required. Here sensitivity list is IP. So I need to write IP in the sensitivity list of this always block. Begin. OP is equal to 0. That means I am defining the default value of output vector OP as 0. Now I can write the select line in the index of this OP is equal to IP. Now when select line is 0, so that means OP0 will be equal to IP and all the remaining bits will be 0. This is expected behavior of demultiplexer, right? Now when select line is 1, OP1 will be equal to input, all other lines will be 0, and so on. Now you see I have written the demultiplexer code, which is very common also. Most of the time we need this generic demultiplexer. So I have written this code in only 2-3 lines, and I am not using any generate for loop. So this code is very simple. Friends, with this let us end this session, and I hope that this would be quite informative for all of you. If you also like this session, please press the like button and share your feedback in the comment section. In future also we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching.